All right. So just like with every mathematical thing we come up with, integers, fractions, all that stuff, we have to be able to perform operations on them. And functions are no different. Here's our four basic operations. Adding, subtracting, multiplying, and dividing. So for these two functions here, if these were two numbers, I would need to know how to add these two numbers, subtract these two numbers, multiply them, and also divide them. So it's actually not that bad. It's pretty simple. If I'm going to add the first function to the second function, this is the format that it looks like. And it implies that I'm going to take the f function, which is x squared plus 5x minus 1, and I'm going to add to it the g function, which is 3x minus 2. So since my operation is addition, I won't need any parentheses. I'm just going to add these two functions together. So what would I be left with if I did this addition? Well, like terms, I have x squareds plus, I have 5x's and 3x's, that's 8x's. And I have minus 1 and minus 2, it's going to be negative 3. So this would be the result if I added them. Subtracting them is a little bit different. I still have the same two functions, so I'm still subtracting the f and the g. The f is x squared plus 5x minus 1, and the g of x is worth 3x minus 2. And in this situation, I'm going to subtract. So I have to be careful when I subtract in algebra that I subtract all of it. So I got to make sure that I put parentheses around that second function. So my first step in this would be to make sure that I have x squared plus 5x minus 1, and that I distribute my negative sign to these two places so that I'm actually subtracting 3x and subtracting negative 2, which is plus 2. So now once again, like terms, I should be able to combine and get x squared. This time I'm only going to have 2 x's, and minus 1 and 2 make plus 1. So key step is right here, and it is distribute. All right. Next one, I have f times g of x. So this one gets a little bigger. So once again, my f function is going to be x squared plus 5x minus 1. And my g function is going to be 3x minus 2. And since I'm multiplying, I want to make sure that I multiply all of this times all of this. So this is a big distributive property problem. So let's start with our 3x. Let's distribute backwards. I'm going to multiply my 3x times every single term over here. So 3x times x squared, 3x cubed, 3x times 5x, 15x squared, 3x times minus 1, minus 3x. Then I slide over to my minus 2. So minus 2 times negative x squared, I'm going to line up with my x squared since I'm going to have minus 2 x squareds. Negative 2 times 5x minus 10x, and negative 2 times 1 plus 2. So I would end up with a grand total of, slide this up a little bit, 3x to the third plus 13x squared minus 13x plus 2. So that would be f times g of x. Last one, f divided by g. So in this situation, I'm just dividing, so I need all of this. So I need the whole f function, x squared plus 5x minus 1, all of that, divided by 3x minus 2. So when I divide, I'm just going to write it like a fraction. Seems to be the most logical way. There's nothing I can cancel, and I can't factor, so I actually have this as my answer. This is actually it. And since we have some x's in a denominator, we have to be careful. Remember, our denominator is never allowed to equal 0. So this 3x minus 2 cannot equal 0 ever. If this equals 0, we have a denominator that has 0, and that's not mathematically allowed. So that means 3x would equal 2. So x and 2/3 are going to be numbers that are not going to work out. So we're going to make sure that we include the fact that x can't equal 2/3 in our answer, and that is called an excluded value. It's the only number that we are not allowed to use for our x. So it's a special number and we cannot use it. It's called an excluded value because it makes the denominator equal 0.